we're 30% of the way there now, up to session 9. And now we have Bruce Walker, who's a project director at Weber Australia. He's done some other really cool stuff, which I've seen, and we might talk a little bit about in the Q&A. I won't kind of breach on it now, but there's been some stuff that Bruce has got to work on over the years that I've seen that I think a lot of us would be envious of. And today, he's going to show us the various ways in which content can be created. So he's going to go through all of the different tools that are within Archicad to then demonstrate the different ways and what's the pros and cons between each of them in terms of how you can make content for certain things, be it a table or a light or something. We'll wait and see what he has to offer. But I now will hand you over to Bruce.
Hello and welcome to my presentation on custom object creation. My name is Bruce Walker and I've been using Archicad since 2004, or for those of you who count by versions, version 8.1. We have a lot to cover in the next 40 minutes, so I'll get straight into it. Why custom content? By content, I mean objects. I'll presume that by the very fact that you're watching this presentation, that you have encountered the situation where the out-of-the-box library parts don't quite do what you need. Over the next 40 minutes, I will demonstrate 4 different techniques by which you can create your own custom content. They are Save as Object, the new Library Part Maker, the new Paramo tool, and finally GDL itself. I'll finish off with some links to further help and learning. For all 4 methods, I will just be creating a simple IKEA desk. I've done this so that you can concentrate on the methods being presented and not be distracted by the geometry. This technique is the quickest and easiest technique. However, it also offers the least parametric flexibility. I've created the geometry I want, so my desk has been created using native Archicad elements, in this case just columns and a slab, and I have the materials applied that I want in the final result. The object origin will be determined based on the file origin itself. So the next step is to move my geometry around the file 000 point. So you can see there, X, Y, and Z is 0. That will now be my origin point for my object. I now select all these elements that I want to form my object, and I save selection as object. In the menu system, it's under File, Libraries and Objects, Save Selection as Object. I'm then presented with this dialog, which gives me the opportunity to rename parameters. These are non-geometric parameters. I'll rename the first 2 so you can see what effect that has in the final object. So desktop and leg surfaces, click OK, and my object is created. So if I activate my object tool, you can see that it's pre-selected here, ready to go. And if I place it, have a look at it, it looks just like my geometry, except it's an object. To finish the process, what I would want to do is add a preview image. If I open the object settings, you can see that it's just got the object icon, which is not very helpful to the end user. So what I will do is, with the object selected, I'll open it for editing. When I do that, it will open up the object dialog, as you can see here. And down the buttons here, down near the bottom, there's one called Preview Picture. When I click on, I'll open a window like this. Now, I've previously taken a snapshot of my 3D image. I use Snagit. Windows will have an inbuilt snippet tool that you can use, and Apple's have their own screen capture tool as well. So you just paste your image from the clipboard. So save that down, and there I go. I've got my preview picture. My parameters have been renamed desktop surface and leg surface. And if I change those, you can see, say, finish blue cobalt. tabletop, the desktop changes, and if I white legs, the legs change. And that's it. The downside of this technique, there are two downsides. One is that this size is not fixed. So if I were to change this size up to say 1500, you can see that yes, it's applied the size change, but it's just applied a scaling to the entire object. So these legs have been stretched, which generally is not what you want. The other downside is that if the geometry changes for whatever reason, so I'll just apply a rounding to these corners. To update this object, you repeat the process. So I select all of my 3D elements. I save the selection as an object, save over the part. And you can see with the dialog I've been presented with, it's reset any parameter name changes I've previously made. Once again, you can see that this has just applied a scaling to the entire object. And if I open the object settings, my preview picture has gone. So that is technique one of this save as method. The second technique that you can use for this save elements as 3D object is to create a new object right from the get-go. This time, instead of doing save as, I will create a new object. And I'm presented with just a blank object dialog, nothing in it. So if I click down these, there's nothing in it. Now the trick to this technique, I need to restore down my plan. So on a PC, it's the restore down button at the top right here. On a Mac, it's right click on the tab and choose undock. Now what I want to do is drag my 3D geometry into my 3D script window. So I click on my 3D script window here. On my plan, I select my geometry and I drag and drop. The catch here is that it needs to be on the drag pet palette icon before I start to drag. So if I click on that, I can't drag it into the window. So I've now activated it, hit escape and go again. Click, hold, drag. The marquee icon needs to appear next to my mouse cursor. I release and you can see it has translated that geometry into a script. The next step is the 2D window. So I click on 2D and I only want to drag in the stuff I want to appear in my plan. So I don't have my legs selected in this one. Click on the desktop, make sure my drag icon is active. Hold, drag, marquee square has appeared next to my mouse cursor, release. There's my script. And then I'll put in my preview picture. Save it. And just like the first technique, when I activate my object tool, it's selected, ready to go. Have a look in 3D. It's the same as before. It's an object. The difference with this is it can't be stretched. The geometry is fixed in size. The attributes are fixed. So I cannot change the surfaces, the fills, the line types, or anything like that without applying an object-wide override. Updating this object is done by repeating the process. So if I close this window, apply my corner rounding as before, I select an object of that type, open it for editing, go to my 3D window, Control All and delete my entire 3D script. Select my new geometry, drag and drop into my 3D script window. Same for the 2D window. Delete the entire script, drag across that which I want to appear in the plan view. Just another tip, Archicad automatically creates hotspots at the bounding box of your object and one at the centroid, as you can see here. If you want extra hotspots, you can have those appear in your script by simply placing a hotspot wherever you want a hotspot to appear. So I'll select my desktop and my hotspot, drag it into the window, and if I check my 2D view, you can see that it's got a hotspot there. The way that works, when I place my object, so I save my object, you can see that it's updated and it's got my hotspot there. However, you can also see that the other bounding box hotspots have disappeared. To fix that, I open my object for editing, and under the Details tab, under Compatibility Options, I check Hotspots on Bounding Box. And there you go. It's got hotspots on the bounding box and at the centroid, and the one that I created there. So these are the two techniques by which you can save 3D elements as an object. This method gives the end user a little more flexibility over how the object will be displayed in different model view options. However, the geometric limitations are still there. This method is only available for SSA and forwarded customers, and it is an extra download and installation. Once you've downloaded and installed it, you will be able to find it under your window, palettes, library part maker. This palette that pops up, separated into a number of sections. The top is the name and design area. Now, when you add a new part name, that is not actually adding the library part to your library. What that is doing is defining a new bounding fence within which Archicad will look for elements to define. Define library part, this is where you assign things to appear in different model view options and highlight them. Property scheme, we'll just use the Archicad listing parameters. Details, this is where you define your library part name, and then the final check and save. So we'll now create our desk object. First thing is to create a new design area. Just to demonstrate how this name differs from the final object name, I'll call it design area. Now we'll mark the design area, and I'll just set a fence 10 by 5 meters. The other thing you now need to do is to put down your level dimensions. This is how Archicad defines or recognizes what belongs to what view. I'll assign these to views. I'll assign the top one to my 3D model full, and I'll assign the bottom one to my 2D symbol full. And just to see what has been assigned and what has not been assigned, I can turn on this highlight active component. So 2D symbol full, that's been assigned. 3D model full, that's been assigned. So this is the geometry that I had created before. So I'll just put this geometry with that level dimension as the origin, and I will assign it to be the same as what that level dimension is, which is 3D model full. Then I need to create a 2D corresponding definition. It doesn't have to be 2D parts. So it's still a slab, but I'm now saying that this belongs to my 2D symbol full. The library part name, I'll change to be what I want the object to be, and you can see that it's still kept the design area as one name, and now the object will be called different. This is where I can define my preview picture, so I can do it before I save. I can also do it after I save. The final step is to save your object, but you can see here I can't save that yet. That's grayed out, because what you need to do first is to check the object. So I'll check it, and what that will do is that will go through the entire design area for this part that I've defined and make sure that what I have put in here has been assigned and it works. And you can see here, no issues found. At this time, I can also rename the parameters like I did in the Save As method. Save As. And as with the previous option, it's pre-selected that object ready for placement. So I'll place it, have a look at it in 3D. Now it appears like this because I still have my highlight selected components turned on. So I'll just turn that off. And there we go. There's my desk. Have a look at it in my object selection settings. Here's my renamed parameters. There's my preview picture. And if I change these surfaces, they work as they did previously. Now you've probably noticed that it only has the one hotspot here. There are two ways that I can go about fixing that. One is that I can open this library part, as I did in the previous version. Open library part, compatibility options, hotspots on bounding box. And there's all my hotspots appeared. The other method is that I can actually place individual hotspots where I want them to appear. So I've taken the desk that we worked on and created some copies for each of the model view options, and just created a little bit of visual difference so that we can tell when we switch model view options. I've checked the assignment of each, so 3D model full, 2D symbol low, and so on, and I've added hotspots where I want hotspots to appear. The other settings are as we left them, so I'll now run a check. Now I do get an error this time, and that's because I've added some lines and text to help me lay out the different view options and so that I can keep track of what's what. That's not critical. So I will save as my object, save over what was there before, replace it, and my placed object has been updated. So if I now flick through the model view options, floor plan is on full. Medium had the chamfered corners, so there we go. And low had the square corners. There it is. And if we have a look in 3D and go through these again, schematic had the square corners, simplified had the chamfered corners, and full had the rounded corners. So the updating process with the library part maker is a lot smoother than with the save as method, and you have more visual control. Paramo, like library part maker, is a recent addition to Archicad. It also is only available for Archicad SSA and Forward subscribers. However, it's not a separate download, but has been built into Archicad from version 23, update 3. You can get to the Paramo file manager via File, Libraries and Objects, Paramo Manager, and you can see a couple of other options there. I've actually created my own toolbar icons, so I just can click on that. You are presented with your Paramo Manager dialog, in which all of your Paramo objects will appear. You can see I have none at this time, so I'll create a new one. First thing we'll add is a block for the desktop. It's a good habit to get into to rename things, so this would be the desktop. We would need our length, our width, the overall desktop height. So once again, we'll rename these so that we can tell what they are, because this will quickly get quite spaghetti-like. Height can stay the same. You've also got some tools to align and distribute these nodes. So let's plug in our length to our size X, plug in our width to our size Y. So our length will be 1, and these dimensions are in meters. 600 wide, 730 high. So you can see that when I changed it to 600, this block changed size Y. We'll now need a length for our desk thickness, and it will be 35 mil thick. And we'll plug that into our size Z. Now you can see that our desktop has updated to the correct size, but it's sitting on the deck. We will want to raise that up. So what we need to do is we need to transform this block. We'll do that with a move node. Now I can come down here and add in a move node. You can also add any node by double clicking on the canvas. typing in what you want. There we go, move. So we want to move it up, the height. Offset Z, transformation, and it's popped up like that. But as this block draws from the base of the desktop, it's actually the desktop thickness higher than what we want it to be. So we want it to move minus the desktop thickness. To do this, we will need a maths node, subtraction. So our A input will be our height. Our subtraction input will be our desktop thickness. This will output our offset Z move. So if we keep an eye on the desktop, when I release this, it's dropped down that desktop thickness. We'll want a surface node in here as well, and a pen node. Surface, this will be desktop surface, and for this one we will create a parameter. So when the user sees this at the end, it will have a parameter there. We'll make sure that the name that the user sees makes sense. The pen, but we won't create a parameter for that because we want to fix that to our company standards. So the pen gets plugged into the pen. The desktop surface will get plugged into the surface. Okay, there we go. So that is our desktop created. Now we need to create our legs. This will be, well, we used a column in our Archicad environment, but we don't have columns here. The closest thing we have is a cylinder. So what we'll do is we'll drop that down in here. We'll plug our pen into our pen. We will want to create a leg surface. So if I hold down Control before I click and drag a node, it will create a copy. We'd still want to create a parameter for this one, leg surface, and this will be that. We'll plug our surface into our surface, like so. What we want to do now is set that to the correct diameter. So I'll have another length variable in here. We'll call this leg diameter. We're not going to create a parameter for this. It's a fixed value. That fixed value is 40 mils diameter. However, when I go to plug it in, you'll see that the input that Paramo is looking for is a radius. So I'll grab another maths transformation, and this time it will be a division. Our input into A will be our leg diameter. Our divisor will be 2. That will output half the diameter, and we'll plug that into our radius. There's that. Now we want to set our height. Now our height will be the height of our object, which is 730 mil, minus the desktop thickness. Now we've already done that. We've done that here. So we can use that same variable for our height. Just drag that node across to our other input, and there we go. The leg has now reduced to the correct height. You can also now see that it's sitting on the corner. We don't want that. We want it to be inset from the edge, from the corner. So we need to do another move node. So if I drag this and hit Control, it doesn't work. I need to hit Control first, then drag a node. Now what is the offset? That will be its own offset. So we'll grab another node here, and the value for this is 85 millimeters. That will be the same in the X and in the Y axes. So if I now plug that into my transformation, you can see it's offset the right distance in the X and the Y axes. The next step, of course, is to create my multiples. One way to do this is to use a grid points node. This will create an array, as you can see, demonstrated by this little icon here. So the size of my X, let's just plug in my length, and the size of my Y, we'll plug in my width. The count along the X will need an integer, a whole number, and I'll make its value 2. So the count X is X. The count along the Y, it will always be 2. So I don't want an integer for that, not at this time. So I can just plug that into the node settings. Count Y is 2. The next thing is to deconstruct these points. But we plug our variable into our point like that, and that will give me a bunch of X, Y, and Z outputs. I now want to move these points in the X and the Y direction, and I want to plug that into my transformation. There we go. I've got my legs in my X and my Y axes. If I change my leg count for my length, you can see that it's updating, dividing it nice and evenly along that axis length. Leave it at 2. But you can also see I've lost my offset. So how do I get my offset back? Well, I need to use a combination. Under transformations, it's a combination node. I want to combine this move. Now I can plug that into transformation 2 and then overwrite this node, or I can hold down Control and drag that node over to here. That will reconnect that node. To delete a node, you right click on it and disconnect it. So I want my combination of this move, and you can see that it's disappeared off my preview, and the move that offset that leg. So where was that offset move? My leg offset into my move here, and plug that into my transformation 1. Now if I put that output transformation, or combination rather, into my transformation, it's offset my leg and it's run my array, my grid points. But now you can see the problem I'm faced with is that it's taken the entire length of the table and offset. So this is poking out the distance of my offset. So I need to correct that. Keep your script as clean and neat as possible, because we're just creating a simple table, and you can see we've already got a number of nodes. Very easy to lose track. We have offset our leg, we've got our length. Now I need to correct this grid points with my leg offset. So the way I will work that is I need to use an expression. So I'll plug in my expression here. For my A input, I want my length, which is there to there. Then I want to subtract twice my leg offset. So I'll plug this into B. So you can see my expression down here is input A plus input B plus input C plus input D. And the way you define that as a variable is it's got to have the $sign in front. So in this case, I don't need C and D. I want to have my length, which is A, my length, minus B, which is my leg offset, and I want that to be twice B. Go OK, plug that into my size X. There we go. Now I want to do the same, but for my width. So plug that in there, plug that in there. Because I made a copy, it's kept the same expression. Plug that into my size Y, and there we go. I've got my desk. So once you're finished, you click OK, and this is when you name your new object. There it is, ready to go. Still not saved. And I'll click OK. Now it's saved. Your objects are ready in the embedded library. You'll see in here that under my embedded library, I now have a Paramo folder, which Archicad has created automatically. And there is my desk. As with the other methods, if I now select my object tool, it will pre-select the object I've just created, and I can place it. Archicad has placed in the 4 bounding box hotspots and hotspot in the center of that bounding box. And as you can see here, there's my desk. Let's select it, open it. There are the parameters I told it to create. And you can see also that the preview picture needs to be added by me. But as with the others, that's changeable, right? Let's change to paint. That's changeable. There we go. Now, the other good thing about this method is that this is geometrically parametric. That's a mouthful. So if I change this desk to 1500 long, these legs have maintained their shape. They're still circular. If I shrink this to be 500 high, that desktop is still maintained its thickness. If I want to edit this object, I make sure it's selected and I choose my open selected Paramo object. The other way is to do it from the manager. So you open the manager, there it is, I can select it and edit it. To add in my preview picture, I open this object like I did with the other methods. Open object, go to my preview picture, paste in my image, and that now has my preview image, still recognized as a Paramo object. So if I open it for editing, I want it to turn on this leg count. So let's go to node settings. Yes, I want to create a parameter, save it, we'll update it, and there it is. I didn't rename that parameter, which I should have, but if I change that, it will change in here, as you can see. Now, there's no way in this to prevent the user entering a value that's going to break the object. So if I put in here 1, which is an object that doesn't work with my nodes, I get an error. So there's no way to prevent that. The other thing is, the 2D view is merely a projection of the 3D script. So there's no masking fill applied to this object. Another thing is that there's still reasonable limitations on how complex you can get with your geometry.
Now, I did find a couple of ways to create more complex geometry, but it does mean delving into GDL scripting. So I used a couple of nodes, which is GDL object and GDL shape. So GDL object allows you to call in another object in your library. So I have a standard block called block rounded, and I used that to create my rounded corners. The GDL shape allows you to script a shape using GDL code, but that kind of defeats the purpose of doing everything with nodes and avoiding GDL scripting. So there are ways to do it, but you do have to delve into GDL. Also, the resulting plan representation, you get this segmentation and not a nice clean radius. However, if I was to stretch this, unlike the save as method, that has maintained its true radius. It just has that segmentation. This is the most powerful, flexible, and comprehensive method available by which to create custom objects. However, it is also the least accessible to the general user given its complex nature. What I'll do in this demonstration is run the process at high speed, and I'll offer some commentary as we go.
Upon starting a new object, I'll also open an object of a similar type so I can copy across from it. Set my subtype, fill in my details. Now I'll copy across parameters as I need. And rename them as required. Set my default dimensions and copy in some starter code to each of the scripts that I'm going to be using. Put in some base dimensions that are fixed. The user won't have access to change these. And then start my 3D script. Copy across what I need from an existing object. Add in some subroutines. The desktop, building materials and surfaces are set. Copy across a prism command, which is an extrusion, and set the coordinates. I'll check my 3D, and there it is. Need to add in a transformation so that it raises up the right height. Now I'll program my legs as a subroutine. Make sure that the material and surface is set. Copy across another extrusion command, a prism command, and change the parameters as required. Put in a loop. Well, first of all, add in the offset for the leg. Now I'll put in a loop so that I get my leg multiples. Then I'll put in a nested loop so I get the other side of the table. And there's my object. Copy in my preview picture, save my object. Now when I place my object, there will be no 2D, you won't see it. And the reason for that is there's no 2D script yet. So I'll uncomment this projection command, which will project the 3D script in the 2D window, just as a way of checking to make sure that my 3D is correct. Now we'll script the 2D, copy across from an existing object what I need. Poly command is essentially a fill command. Copy across the coordinates from the 3D script and change my status codes as required. Check the 2D preview, and there it is. It's got a masking fill, and it's the correct size, and this is a fully parametric object. So if I stretch it, the only things that stretch are the things that I want to stretch. Desktop stays the same thickness, the legs maintain their shape, their offset is true. Now let's put in the corner radius option. So I'll put command, tells Archicad, remember these numbers until I ask for them again. And the get NSP says, use the numbers I asked you to remember. So this is a way of inputting different coordinates for different selections without changing the final command. I'll add in some limitations to the values that the user can enter so that they won't break the object by entering in invalid numbers. Add in a selection parameter, 1 for square, 2 for rounded, and then some if statements so that the correct coordinates get entered into memory depending on the user selection. So you see desktop type 1 has been entered previously, desktop type 2, which is our rounded corners, enter a different set of coordinates, but the final prism command remains the same, just uses the new coordinates that have been entered into the memory. Let's check it. The corners are rounded. Now you'll see that there's segmentation to those corners, to that rounded corner, and I have control over that with the resolution parameter. So if I change that to a higher resolution, you'll see that that segmentation gets smoother. Now we'll update our 2D script, and you can essentially just copy across your 3D script and make some changes to the status codes to suit the 2D environment. A nice smooth radius for a good plan representation. If I uncomment out that project command, you'll see the segmentation, the difference between a 3D and a 2D script right there. Comment that back out with an exclamation mark. And there's my 2D representation. Set my default back to square. Save the object. And we're done. Let's test the selection in the Archicad environment, and it's updated. It's kept its true shape, hasn't stretched, hasn't scaled. It's only changed what I've asked it to change. Now, if the base geometry changes, I can make some minor changes to the master script, and it updates project-wide. No input required from the user. So this is definitely the most powerful way to create your GDL objects. If you would like to research further any of these methods I've just demonstrated, the online Archicad help is a good place to start. Each of the methods I went through have their own help categories. Save as object, which is under elements of the virtual building, parametric objects, create custom library parts and components. Library part maker has its own subcategory, as does Paramo. GDL also has some help and links here. The Graphisoft community forums are an excellent source of knowledge and experience, where you can either get your questions answered by veteran users or see if the questions you have already been answered. The developer section is where these discussions take place. YouTube is another great source of knowledge and learning. Archicad has its own channel, and other users also post valuable content in their own channels. For GDL, the reference guide is available within Archicad itself under Help, Documentation, GDL Reference Guide. This is a PDF of all the GDL commands and how to use them. The online version is available at this link. There is also a free book that you can use to teach yourself GDL. It's quite dated now, so it doesn't have the commands that have been added in the last 15 years or so. However, the logic and structure of GDL hasn't changed, so it's a useful resource to make your start. Version 3 is available at this link, which is listed under the online Archicad help I mentioned earlier, and version 4 is available at this link, which you can find with a search on the community forums. My hope in doing this presentation is that you give it a go yourself and not be daunted by the prospect of creating your own objects. Start simple and build from there. Thank you for your attention.